Brought to you by the Astro Youth House chapter from STEM Arts Lab, Space on Earth is a student-led podcast that inspires listeners who are curious about space to explore the wonders of the universe through the voices of young thinkers, creators, and dreamers.
Each episode blends personal curiosity with scientific discovery, from the mysterious depths of black holes to the practical impacts of space on Earth, like GPS, climate science, and medicine.
Hosted by STEM Arts students from Taos, New Mexico, this podcast draws connections between space, art, and science, how these things all impact us here on Earth, and their meaning to humanity.
You'll hear raw, insightful conversations about topics like light pollution, the overview effect, lunar exploration, and the societal impact of the space race.
Whether you're into exoplanets, dark energy, or just stargazing from your backyard, Space on Earth makes space personal, accessible, and inspiring. We believe that space isn't just for astronauts and scientists, it's for everyone.
Join us on this adventure as we explore the cosmos from Earth, one story at a time.
Special thanks to the Lore Foundation for helping launch this podcast.
Hello, everybody. Welcome back to the Space on Earth podcast. I'm Wyatt Wade.
And I'm the other host, Lacey.
And today we are covering America's second step in our grand return to the moon. That's right, everybody. Artemis II launched, and there was a lot of drama on this path to get here. Several weeks of delays, but we did it. And as we record this, the Artemis II crew are on their way home. This is being posted the day they land. Anyways, this mission has been just great, really. There's a lot of stuff to cover. But first, Lacey.
All right, before we jump into all the technical stuff and all the important updates about Artemis II, let's talk about the cultural stuff and the cultural importance. For starters, we have a really diverse crew. One of the mission specialists is Christina Cook. She's going to be the first woman to go to the moon, and fun fact about her, she spent the longest single spaceflight by a woman, which was 328 days. The pilot, who is Victor Glover, will be the first Black person to go around the moon. And the other mission specialist is Jeremy Henson. He is from the Canadian Space Agency, and he'll be the first Canadian to be involved in a lunar mission. That's quite amazing to have such a diverse crew and so many advancements compared to the Apollo mission, which was just white men. And also, the name Artemis actually greatly ties into Greek mythology. Artemis is the Greek goddess of the moon, and she is the twin sister of Apollo, who is the god of the sun, which was the name of the previous mission in 1965 to 1972. The spacecraft that the crew will be on is called Orion, which is a recognizable constellation, and in mythology is actually a hunting companion of Artemis. All right, wrapping up with all of that mythology and cultural stuff. Wyatt, do you want to talk about what happened before the launch?
All right, yeah, very cool. Now let's actually get into the main event. Last time we talked about Artemis II, NASA didn't even attempt a wet dress rehearsal yet, which is when they fuel SLS, the rocket, and simulate a countdown. So it was late January last time we talked about Artemis. We had some delays. There were some issues in the first wet dress rehearsal. There were fuel leaks and software issues on the first WDR wet dress rehearsal in early February. So we had to say, no, we can't launch in February. We're going to take time to solve these issues, replace some things, and then we will do another wet dress rehearsal in March. The second WDR went really well, so we thought all the issues, the leaks on the core stage from the first WDR, they were solved. They solved the hydrogen leak issue. You know, hydrogen is a very small chemical. It's an element, really. And it would leak through the fuel lines on the core stage. But they fixed that after WDR1. But with WDR2, now instead of the first stage being the issue, it was the second stage, the upper stage, the interim cryogenic propulsion stage manufactured by United Launch. Instead of hydrogen, it was a helium leak on that upper stage, and they couldn't access the ICPS from the launch pad, so that meant they had to roll back SLS and Orion back to the vertical assembly building, be able to access the upper stage. So that then pushed all the March launch windows off the table. But mid-March, they rolled SLS back out again, and we're targeting April 1st to return humans beyond low Earth orbit. The first time since 1972, actually. On March 27th, the crew arrived at the Kennedy Space Center for their continued quarantine, because if they get sick, it's better to be sick while still in quarantine so they can recover, and then they aren't going to be sick in space. That would cause more delays. Then March 30th, the countdown began for SLS. T-minus 6 hours, the crew got into their nice, very cool orange spacesuits. I really like those designs. T-minus 3 hours, that is when they arrived at the pad and got into Orion. Then everything was looking good. I mean, it was a very, very smooth count. We only had a slight hold. We launched, I say we as if I work at NASA. I don't. I just say we as humanity, as in humanity. Yeah, you get it. They launched only 10 minutes into the 2-hour launch window. So it was a very smooth count, really. So T-minus 7 seconds, the 4 RS-25 engines on the core stage from the shuttle program ignited successfully. Then at T-minus 0, the solid rocket boosters ignited, and SLS and Orion and its crew lifted off pad 39B. 2 minutes into flight, the solid rocket boosters shut down as expected and separated from the core stage, and the core stage kept powering Orion into space. At around 8.5 minutes, the core stage shut off, and Orion and ICPS separated. And now they were in a highly elliptical, technically slightly suborbital trajectory. You see, the perigee, their lowest point of orbit, was slightly in the atmosphere to allow for, 1, the core stage to re-enter the atmosphere, and 2, Orion to re-enter the atmosphere if anything went wrong, which, well, nothing went wrong. So T plus 50 minutes or so, ICPS ignited its RL-10 engine. Isn't it RL-10? It is an RL-10. I remember my engines. ICPS ignited its RL-10 engine to boost itself into a actual orbital trajectory so it wouldn't hit the atmosphere and re-enter. And they did a few more burns after that. I think they did 2 more burns to get into a high Earth orbit with a orbital period of about 23.5 hours. And then it was really time for the testing to begin.
Orion separated from the upper stage. The crew then conducted a proximity operations demonstration using the ICPS as a target. Over approximately 70 minutes, Victor Glover, who is the pilot, took manual control of the spacecraft and performed a series of maneuvers to evaluate handling qualities and practice techniques for future docking operations. The ICPS was equipped with a docking target, enabling test of Orion's ability to manually maneuver relative to another spacecraft using onboard navigation sensors and reaction control thrusters. Following the demonstration, Orion returned to automated control while the ICPS performed a deorbit burn for destructive reentry over the Pacific Ocean. Destructive reentry meaning all the materials were burned up in atmosphere. But after these operations, the crew reconfigured the cabin for spaceflight, set up their flywheel exercise device, and used it to conduct a life support system stress test through physical activity, and then had dinner.
All right. So on flight day 2, after completing high Earth orbit operations and system verification, so the crew were just sitting in Earth orbit. They still weren't on the trajectory to the moon. But on flight day 2, they initiated the around 6-engine TLI burn. TLI stands for trans-lunar injection. That means now, instead of just sitting in high Earth orbit, we are actually on a trajectory, or we have enough speed to, go to where the moon will be in 3 days. And that burn was used by the AJ-10 engine. I think it uses hydrazine. It was used on the space shuttle during the space shuttle program. This exact AJ-10 on Artemis II actually flew on space shuttle Atlantis. That's one of the, benefits of SLS is that we just reused a bunch of shuttle hardware with some pieces actually flying on shuttle missions. So that's kind of cool. And that trajectory, it was a free return trajectory, just like Apollo 13, where we'd fly around the moon and then go straight back to Earth. We would not need another burn to go back to Earth because we are going into lunar orbit, right? We're going to Earth. We launch from Earth. We sit in low Earth orbit, or high Earth orbit. We're going towards the moon. We don't slow down when we get to the moon. We don't slow down to get into moon orbit. We just fly right by it, and then we are back on our way to Earth. On day 3, the first of 3 planned outbound trajectory correction burns were deemed unnecessary. The second one, too. Basically, these would be little correction burns with the same AJ-10 engine to slightly move the trajectory. But the TLI burn, it was a perfect trajectory. The toilet on Orion did have some issues. There were some frozen vent lines preventing it from being dumped into space. But when rotating Orion into sunlight, the vents melted and they were able to be used again. Yeah, they had a couple issues with the toilet on this mission, but they fixed it. I think the longest downtime they had with it was probably 2 hours or something. On day 4, you know how Lacey talked about Victor Glover doing his little manual control of Orion and station keeping with the ICPS. Christina and Jeremy took turns manually controlling Orion themselves, to evaluate its performance in deep space, just like Victor. Over 40 minutes, they tested 2 thruster control modes to provide, the engineers back on Earth with further data about, how well Orion works. I'm pretty sure during Victor's turn back on flight day 1, he actually, because Victor, this is, I think, Victor's second spacecraft. He's flown on the SpaceX Dragon and now Orion. I think he said handles it's more smoother than Dragon. So that's kind of cool. I don't think he flew on the Russian Soyuz. No, I think he flew on only Dragon. On flight day 5, how I was talking about the outbound trajectory burns earlier. The first 2 of 3 weren't necessary, but that third one was. It was, I think, a 20-second burn or something. But, just slightly correcting the spacecraft's trajectory, just fine-tuning the apogee, or highest attitude, or not attitude, altitude above the moon, and consequently slightly moving the return trajectory of Earth. Anyways, it was a completely normal burn done with the AJ-10 engine, just like I said, the one that flew on Space Shuttle Atlantis. Really cool that they can, reuse all this flown hardware, but then also really sad because then it just gets destroyed after it completes its mission. And put in a museum instead. But, I would rather have us return to the moon finally after 50 years instead of something that could be, something that has sentimental value, but could also be useful. I'd rather it be useful than just sit in a museum for the rest of its life. Then on day 6, Monday, the 6th, yes, April 6th, this was the main event. Orion and his crew were now finally flying by the moon. I couldn't watch this live. I kind of did. I had the live stream playing on my phone and I was listening to it. But man, the photos that we got from this were just amazing. I should probably actually describe the actual, events of the flyby. On day 6, Orion entered the moon's sphere of influence, where lunar gravity became the dominant force shaping its trajectory, like the moon is now pulling on the spacecraft more than Earth was. Orion flew around the moon, I think, had its closest approach was around 4,000 miles above the surface, which is like really close. It actually did this mission. It beat the furthest distance any human has been from Earth. Originally, Apollo 13 was like, how do I word this? Basically, Apollo 13's trajectory, how Apollo 13 had that issue where liquid oxygen tank, or no, just an oxygen tank, ruptured on the spacecraft back in 1970, and the crew had to abort the lunar and just go straight back to Earth. Their trajectory was the basically farthest in the entire Apollo program. So that's like the farthest any human has been. But then Artemis II beat that. I don't remember it exactly. It was probably like 250,000 miles. And then I think Apollo 13's trajectory was like 5,000 miles below that. But yeah, it now holds the record as the farthest crew mission from Earth. As Orion flew behind the moon, Orion experienced the planned loss of signal because, you got a giant rock in the way of your antenna. So we couldn't talk to Orion for, I think, around 40 minutes. But then during the time, the crew were taking their beautiful, beautiful photos of the moon. Then eventually it flew back around and we got connection again. Actually, some heavy stuff. During their flyby, the crew observed 2 unnamed craters, which they proposed be named Integrity after their spacecraft. Orion Integrity. It's the spacecraft's nickname. The real name is Orion, but this exact crew module that flew on Artemis II was nicknamed Integrity by the crew, and then they nicknamed a crater on the moon Integrity. But then also the second unnamed crater, they named Carol after Reed Wiseman's deceased wife, who passed away in, I believe, 2020 from cancer. All the communications, all the crew were very choked up. It was a very heavy moment. Yeah, I think heavy moment is a good way to describe it. Back to the mission. After the communication blackout, the crew experienced a solar eclipse. The moon was in the right place to block out the sun on the opposite side of Earth, and they got their own little private eclipse just for the 4 of them. It was really cool. I didn't know that it was going to happen. I was amazed. They did bring eclipse glasses with them. So I guess they knew it might have happened, but still, I think they also got pictures of Venus and Saturn, maybe some other planets too, but that was really cool. Solar eclipse, not from Earth, but with humans. That's really crazy. On day 7, the day we are recording this, Orion and its crew left the sphere of influence, and because they are on a free return trajectory, they're headed back to Earth. They are going to land back on Earth the day this is posted, April 10th. That landing, so it's flight day 10, April 10th. They will re-enter its atmosphere at a very, very fast speed, 23,000 miles per hour, which is really fast. They will land in the Pacific Ocean off the coast of California, I think near San Diego or something. And then the U.S. Navy will recover the crew. And that will basically wrap up the mission. I'm hoping for a future episode. Well, I guess we don't really need to wait for episodes anymore, because I'm happy to announce that we now have our own articles. Wyatt Wade, will be writing hopefully at least weekly articles on stuff going on in American spaceflight. It will be on stemarts.com. If you go to the menu and then youth leadership, there should be a tab called youth spinoffs, and that's where eventually my articles and other STEM arts students' articles will be posted. I'm very excited for this. Sorry for getting off topic there. Anyways, another great episode. Artemis II. Next up is Artemis 3, but we don't really land on the moon until Artemis 4. We can talk about all this on a different episode because in February, after our first episode on Artemis 2, the NASA administrator, Jared Isaacman, love that guy, he made a change of plans to Artemis 3. Originally, they were going to land on Artemis 3, but now they're going to do things a little bit different. They're only going to go to low Earth orbit. But, I think it's time we wrap things up. Thank you all for listening. I've been one of your co-hosts, Wyatt Wade.
And Lacey Collins.
And thank you so much for watching. We will see you on the next episode of Space on Earth.